All right, so here are some examples of the product rule. So remember our formula. Um, if we multiply bases that are like bases, right? In this case, a, then we can just add their exponents, right? So we can get down to a single one of those bases and just add the exponents. All right, so for number one, we have 3x squared times 9x to the third, right? So remember the associated property of multiplication, we can multiply in any order that we want, right? So I'm going to multiply the 3 times the 9 first, just because those are kind of like terms, right? Similar. They're just normal numbers. So 3 times 9, just multiply them like we normally would, right? It's 27. But with our x's, those are like bases, right? And they're variable expressions, so I can't just simplify x squared, right? I don't know what x is, so I can't plug x times x into my calculator. And so what we're going to do is use the product property. So x squared times x cubed, what I'm going to do is I'm going to end up with a single x, but I'm going to add those exponents. So 2 plus 3 is 5, right? And I'll just show the mental math up here just so we see where it's coming from. But I'm just adding these exponents, right? 2 plus 3, that's how we get the 5. And that's our simplified answer. Okay, so 27x to the fifth is the product of 3x squared multiplied by 9x cubed. All right, let's try number 5. So same idea. I'm going to use the associative property of multiplication to multiply the negative 6 and 5 first. So negative 6 times 5 is negative 30. Okay. Then I see that I have like bases, right? I have x squared and x squared. So I'm going to multiply those together. So I'm going to end up with one base, and then I'm going to add the exponents. So 2 plus 2, right? So just add these exponents, and 2 plus 2 turns out to be, that's right, 4. All right, so negative 30x to the fourth. Number 7. So I'm going to multiply negative 9 times 3, get positive 27. And then now I'm going to multiply my x's, my like bases. So I have x to the 10th multiplied by x to the 7th. So I'm going to get 1x as a result. And I'm going to add the exponents, 10 plus 7. So we get 17. So it's 27x to the 17th. All right. So remember, once again, going back to the rule, what we're doing is we're combining two like bases, and we're getting down to one base, right? So it's kind of simplifying the situation. We went from having two x's now to having just one x, right? So that's what we're looking to do. All right, and once again, just remember, when you multiply like bases, you add the exponents, okay? So when you multiply like bases, you add the exponents. All right, last one that we'll do on this page is, and this is straight out of the book, by the way. And so number 11, I'm going to add the normal numbers, the constants. So 3 times 8 is 24. Okay, then I see I have a W here with the W here. Now, one thing that I referred to earlier, or at least alluded to, is that if you don't see an exponent, there's always an invisible 1 there. So when I have W, it's really W to the first power, right? Okay, so when I multiply W times W to the 7th, I'm going to add 1 plus 7. I'll do that with, so 1 plus 7 is 8. Okay, so watch out for that. Sometimes people forget to add the 1, they just bring over the 7, but there is an invisible 1 there, so 1 plus 7 is 8. And now I see I have another variable, right? I have t going on as well. So I have a t here and a t to the 6th here. So remember, there's an invisible 1 there. And so I'm going to bring over a t. I'm going to add those exponents, 1 plus 6. And that turns out to be 7. that's our answer. All right, so let me know if you have any questions on that. But that's the product rule of exponents.